Good evening, everybody, and welcome to the Google for Education Next Practice webinar. We are absolutely delighted to spend this evening with you. I'm with my wonderful colleague, Dr. Rebecca Vivian, who is a CSER researcher and has an expertise in coding and computational thinking, teaching kids. So just to give you a little bit of background on Rebecca, she is a postdoctoral researcher with the Computer Science Education Research Group at the University of Adelaide. So she's done a lot of work in education, but is also Google Certified Innovator. And just to embarrass her, was recently recognized as a new voice in education research by the Australian Council for Educational Leaders. So it's absolutely, we're delighted that Rebecca can be with us tonight. So just before I pass over to her and let her do her thing, just a few reminders. Firstly, you are watching this in a Hangout on Air event. That means in the top right-hand corner of your screen, you will see a Q&A app. That will allow you to ask any questions that you want to ask. And if you just pop them in, I've got a lot of people saying hi and all that kind of stuff. If we can actually avoid using the Q&A app to say hi, if you can use the Q&A app just for specific questions that you have for Rebecca, then I will be able to manage those questions and ask her the questions at appropriate breaks during the rest of the evening. We are very, very excited to have well over 200 people registered for the webinar, which is wonderful, from all over the world. We've got people from Mexico, we've got people from the States, we've got people from India, Malaysia, China. We've also got people from Europe as well as a pile of Kiwis and Aussies. So thank you so much for giving up your time. I know that you're going to have a wonderful professional learning moment with us, and I will, with no further ado, pass you over to Rebecca.
Thanks, Chris, and thank you so much for inviting me along to talk about coding and computational thinking. I'm really excited, and it's definitely something that we're passionate about sharing with the community here at CSER. And so I think I'll just go to the overview of the webinar. So I'll just screen share. Okay, so I guess just first up as well, I've just added our Twitter handles. So if you're on Twitter, you've got Chris Hart at C Hart and myself at Rebecca Vivian. Okay, so in this webinar, we're going to be looking at some of the following aspects around coding. And we're going to firstly start by looking at, what is coding and what is computational thinking. And then we'll move into looking at some examples of programming environments and some activities that you can do with coding in your classroom. And we'll look at how students can design and evaluate solutions. And also I'll finish off with some, next steps for professional learning as well. And I just wanted to mention that I'm sure I've got a lot of teachers here who are already trying some amazing activities in the classroom, and that's awesome. And I'd love to actually draw on your expertise, your experience, and your advice. So what I've done is I've set up some Twitter questions at the next practice hashtag there. So if you're on Twitter and you're following this seminar, whether it be later or live, feel free to join in the discussion. Throughout the webinar, I've just posted some questions in the red text surrounded by the little text box, and I'm not going to read them out, but I just invite you to share your thoughts around those questions as we move along. Okay, so let's get started with those tweets. So I just ask you to introduce yourself and let us know where you're from and why you're interested in learning to code. Okay, so in today's society, we're surrounded by technology and computer science, and coding underpins a lot of our daily activities and the technologies we use. And we've become very good at consuming technology, but how many of us can actually create or know and understand how technology works? So coding in schools is not really about creating software engineers. It's about building their appreciation and their understanding for how technology works, and also encouraging them to be creators. It can also help them communicate ideas, say in their professional roles when they go out to work in different disciplines. So if they need an app or a website created, they've got the tools and the skills to be able to communicate communicate that across to the people that they're working with. And coding also helps develop computational thinking, which can be applied in a number of different discipline areas, as we'll discuss later. And I just wanted to also add that introducing coding into your classroom can actually inspire someone to consider a computing pathway who may not have considered it before because they didn't really know, what computer science was about or what coding involved. Okay, so I just wanted to share with you some, inspiration and examples of what you can do with code. And here I've got some young innovators and people who are actually creating solutions with code. So in the top left-hand side, we've got Brittany Wenger, who has actually created a less invasive way to diagnose cancer with accuracy. So this was inspired by her family member who was recently diagnosed with breast cancer. And what she did was she went and taught herself how to code, and she explored the research and also the science around breast cancer and biology, and came up with a solution where she could collect huge amounts of data and teach the computer to actually diagnose cancer with accuracy. And on the right-hand side, we've got Kenneth Shinozuka, who has a grandpa who was diagnosed with Alzheimer's. And what they found was happening was that their grandfather in the middle of the night was getting up and bumping into things and having really nasty falls. So what he wanted to do was come up with a solution where he could sense when his grandpa got out of bed. And what he did was he programmed an app to send him a text message using wearable sensors to let him know when his grandpa got out of bed. And that way the family were notified, they could get up and they could help their grandpa. Lastly, I've got Jake Coppinger, who's from Australia, and this is an image from his TEDx Sydney talk. He taught himself how to use electronics, how to program, and he taught himself trigonometry so that he could create an intelligent glove. And he shares his experience in the TEDx talk. So I'll share these slides out with Chris later so you can watch that if you're interested. I guess what I wanted to point out across all of these stories is that the students actually taught themselves to code in order to come up with a solution. But they also were motivated to learn a new topic area. And that's what's quite powerful. So in these stories, these students went and learned about topics in maths, in science, and so on. And coding has a wonderful opportunity to really drive learning in other subject areas. Okay, so I think one aspect of introducing coding in the classroom that's really important is also to help students understand what they can do with code. So just like I've done with those stories, you can draw on inspiration and ideas online. And I've just got some examples on this slide where I find stories of inspiration that I can share with teachers and that I can share in presentations. And we've got the Made with Code Mentors, which is an online website, and they've got some wonderful stories of women who are creators and how they're bringing code into areas like fashion and design and technology. And they're sharing their stories online to motivate other young females or even males as well. Another one of my favorites is looking at the previous entries of the Google Science Fair. And these stories are amazing only because they have students sharing their passions and coming up with problems that they want to solve. And it's really inspiring. So I really encourage you to go and have a look at those past Google Science Fair projects. I've also got a link to, in the slides, which I'll give you later, you can go on and see actually how the Google developers come up with solutions using computational thinking. And there's some really interesting stories and how they come up with that in things like Google Maps, trying to improve the Google Maps, how to bring the internet to the world and things like that. Another really good resource is the Careers with Code magazine. So this is a free online magazine. I'll just go to it there. So you can either download it on your iPad or tablet, or you can view it online. And this magazine, they've brought together stories from all over Australia and I guess the world about how people are using code in their professions. And there's some really powerful stories there, from using it in to diagnose problems in pregnancy stages, and also creating haptic devices for people with disabilities. Okay, and my last inspiration example is on YouTube, and this is a playlist created by Sally Ann Williams, and I'm sure many educators in Australia know who she is, and even across the world. And Sally's brought together YouTube videos where people are showing how technology is applied in all different areas. And this is sort of under the banner of Sally Ann's famous CS plus X idea, which is combining CS with your passion and coming up with solutions. So I'll just show you, if you're on YouTube, what you can do is actually save the playlist. So I've just saved this into my own playlist, but you just click the little save button there. And then when you go back to your own YouTube channel, it'll appear on the left-hand side, which is something very handy if you're looking for videos to use in the classroom. Okay, so just move forward. So what is coding? Coding is also known as programming, and coding is basically the act of putting together a set of instructions for the computer to implement. And I've got some examples of different coding languages here on the screen. So on the top, we've got visual programming languages, and these involve children dragging and dropping, colorful blocks of code in a sequence to form an algorithm. And the top left is the Scratch Junior programming language, and the right-hand side is often used in things like Blockly or Scratch, which we'll have a look at later. Underneath the Scratch versions, I've also got, a language that starts to move from the visual programming language toward general purpose programming languages that they use in industry, but it's child friendly. So you can see there that you can just name the color turquoise, or you can name a shape, which is a star, but it's starting to phase children out of using the colorful blocks. Then the last one there I've got is an example from processing, which is a language that people can use to create digital artwork or animations. And I guess I just wanted to show you the progression from year levels and how it sort of evolves. But all programming languages share common programming statements. So, for example, logical sequencing is one. So it's really important that code has a logical sequence and that it makes sense, because the computer can't guess if you have an instruction out of place. So that's one thinking process that's really important. Then you've got decisions, which is also known as branching, and that means that you're telling the computer to make a decision based on some kind of information. So it might be, for example, if the green button is pressed, then something appears on the screen. And lastly, another example is loops, which is also known as repetition. And this is the idea that the computer is actually really powerful in that it can repeat the same instructions over and over and over again really efficiently. So instead of writing the same lines of code over and over again, you can just tell the computer to repeat that set of instructions a certain amount of times. And as you can see in the top right-hand side, we've got some examples there where people have got the forever loop, and it's telling the instructions to just keep repeating there. So I guess when it comes to explaining these concepts in the classroom, I have a resource that I find is really useful in teacher workshops, and that I just wanted to share with you on YouTube. So these are from the code.org website, and I find that these videos are really useful as a way to introduce these programming concepts. They can also be used to, I guess, inspire an unplugged activity or a discussion, or they can be used just before you're going to do an online coding activity. So on the code.org YouTube site, they've got a whole range of video playlists here, and we've got things like interviews, we've got activities, unplugged activities. We've got inspirational videos. But I'd just like to click on the Hour of Code tutorial videos. So in here you can see a set of videos which are all under 2 minutes in length, and these are fantastic as they explain the things like decisions. So you've got the if-else block, you've got things like loops, and what I do is I usually use these to show students or teachers. So I'll just play one just to give you a feel for what the videos are like.
An if-else statement is a decision between two things. So say, for example, if it's a weekday, it's time to go to school. Otherwise, you can stay home and have fun. Now let's see how we can use an if-else statement with our zombie. This block looks the same as the if block, but there's an extra part on the bottom that says else. If I put a move block where it says do, and a turn left block where it says else, that means the zombie will move forward if there's a path ahead. And if there's not a path ahead, the zombie will turn left. It's making a decision and doing one of the two actions based on that decision. And just like if blocks, you can put if-else blocks inside repeat blocks. Now let's get those zombies back to where they belong. An if-else statement is a decision.
Okay, so as you can see there, even though you're not using, say, the zombie game to teach students, you can still see that there's the common programming statements that are used across any programming environment that you use. So you can explain that to students, and you can use it as a way to kick off those discussions. So I'll just move back.
Rebecca.
Yep.
Hello. Just a couple of questions have come in.
Yep.
So the first one is from Melanie, and Melanie says, when you talk through the programs that are on the slide you're currently looking at, can you list the names of the two programs, Scratch and what was the other one?
That was Scratch Junior, the top left, and then you've got Scratch, just the original, Scratch by MIT.
Awesome, thank you. And then, so that's for you, Melanie. And then Rachel Bath. Hello, Rachel, nice to see you. Rachel asks, maybe a brief answer to this one, which text-based language do you suggest to begin with after visual programming? JavaScript or Python or something else?
Okay, yeah. So I've got some ideas later on. We've used in our introductory programming course Processing.js, but you can also use things like Python, and I guess there's some of those more child-friendly environments that sort of help you, move across to those general programming languages. So I'll come back to that if that's all right.
Yeah, that's awesome. Thank you. Just to remind everyone, thanks for using the Q&A app. Keep asking your questions. There is a lag between the video that you guys see and actual real world, so it might take us a few minutes to get your questions. We also have actions on the Twitters as well, so just saying hello to Rachel Furlong, Kate Wilson, Ash Doyle, Therese Hogarth, Kate Wilson again, and Tashi Martin, who have all said hello to us, and they're mainly from Australia, I think. So back to you, Rebecca.
Oh, thank you. I've just had a poke at the Twitter feed, and it's really good to see you all engaging in the discussion on there. So I'll come back to that after. Okay, so I guess I just wanted to touch a little on computational thinking and what it's all about and how you can bring it into the classroom. So computational thinking is a problem-solving process that computer scientists use to find solutions to problems. And it's a way of harnessing technology to come up with a solution. So I came across this image, which I think someone shared on Twitter, and it just gives a really nice overview of the concepts and the approaches involved in computational thinking. And this is from the Barefoot Computing Group, which is the Computing at School group in the UK, and they have some fantastic resources. So if you look up the CAS group or Computing at School, you'll find their website with all their computational thinking resources there. So on the left-hand side, you can see that we've got the concepts involved in computational thinking. So as you can see up the top, we've got logic, which is logical thinking, so predicting what might happen with a particular outcome. You've got algorithmic thinking, which is thinking about the steps involved to come up with the solution. You've got decomposition, which is, breaking down the problem into parts to solve, but also breaking down your solution into smaller tasks in order to implement it. You've got pattern recognition, so spotting patterns and ways of repeating things a little bit simpler. So if we consider the loops, that's a way of identifying a pattern in coding. So instead of writing the same sets of instructions over and over again, you might actually just identify that as a pattern and create a loop. So it's much more efficient in terms of implementing your solution. Then you've got abstraction, which is being able to, say, describe something at the abstract level. So instead of saying, oh, I've developed this app and it does this, this, and this, and listing everything, I might be able to just describe what my app does at the most abstract level. So perhaps it's a way for people to share recycled goods or something like that. Then you've got the last concept, which is evaluation, and that's making judgments and reflecting on your solution and perhaps thinking of different ways to improve it. And then on the right-hand side here, we've got some approaches, and these are the strategies that you'll use in the classroom and maybe ways that might guide your lessons. So up the top there, we've got tinkering, which is allowing students time to play and explore. And I noticed that was a strategy that someone had mentioned on the Twitter feed before. And we've got creating, which is getting students to design. So think about what they want to create, their goals, and then allowing them the opportunity to make it. We've got debugging, which is a strategy to try and find problems or errors and how we can go about fixing those. Then you've got also down the bottom, you've got collaborating. So coding projects offer a wonderful opportunity for students to work together and collaborate and communicate ideas and share ideas with others. And also I just wanted to touch on perseverance. So coding can be challenging at times, but if you encourage students to persevere and keep going, I guess a strategy with that is also letting students know that coding is about problem solving and it's okay to test things. So you don't have to get your code perfect the first time. You don't have to get your idea perfect the first time. You can actually, problem solve it together, and getting students to work together helps in letting them know that they're not alone. They've got the support and ideas coming in from around them. Okay. So
Rebecca, just before we move on, I do have a question from Dale. Hi, Dale. And I should have said this right at the start, so it's my fault, sorry. Dale asks, are you able to list the links? Rebecca has very kindly created a Google Doc handout, which has got lots of links in there. So we will share that with everyone who is registered.
Yeah.
So yes, you'll be able to get hold of the links and that kind of stuff. And again, Rachel, if some of the Rachel's just saying that on that size share, some of the slides or some of the words are a little bit small to see. You will get a link to the handout, so you'll be able to pick up on anything that you are unable to catch at this point in time. Thanks for your questions. Okay, back over to you, Rebecca.
Thank you. Yeah, so I've got the handouts and I'm happy to share my slides as well, so you can actually go through and click on the links and things that I'm talking about. So I guess I just wanted to recap on some of those points in the computational thinking document. So when we think about creating solutions, whether it be getting a character to move from one place on the screen to another or coming up with an app or a website, there's a set of things that we need to consider with our solutions. So you want to think about what the idea or the goal is and what the steps are needed to solve the solution, how you can go about implementing the solution, and also evaluating and exploring how effective the solution is. So that's just a little recap there. And I guess just before I go into looking at some coding environments, I just wanted to show an unplugged lesson example. And unplugged activities are really useful for being able to explore computational thinking and perhaps some of the programming statements before you jump into an online coding environment. And unplugged activities that introduce algorithms allow students to get a feel for providing explicit instructions, logical thinking, and are really nice just as a way to start engaging in discussions. So I've got this example here from Fori, who's in our computational thinking community. So Fori shared this. It's based on the famous robot sandwich, the robot jam sandwich activity. And usually the teacher in the past has stood up the front and the students sort of call out the instructions that they want them to follow in order to make a sandwich. Fori's flipped this around a little bit, and he's got older students working with younger students. And the older students are behaving as the robot and they're taking in the students' instructions. And the students are collaboratively working out the instructions in teams and then sharing them to the older students to follow. So I'm just going to play this so you can have a look at how this kind of works. I'm just going to skip to, they've just got a little bit of an introduction there. So I'm just going to skip to this point.
How to make butter. By the program, how to make a butter and jam sandwich. Yum. Do you think you can write a program like that?
Yes.
Step by step, thinking like a computer?
Yes.
Now the helpers and the group leaders is going to help you today, okay? So what's going to happen is a creative process. They will help you. The group leaders will come over, give the program to the input device. He will give the commands to the human computer, and he will make the sandwich. I'm putting the computer on. It's up to you, input device.
Computer, move towards desk.
Place it on the plate. I spread butter with knife.
Yes!
Calculating. Step 1, take 2 pieces out of the bread bag. Step 2, calculating. Open the butter tub and spread it on the bread. Step 3, calculating. Open the jam jar and spread it on the bread.
Error. Malfunction. And then we need to debug.
Step 1, calculating. Pick up 1 slice of bread. Step 2.
Okay, so I've just stopped it there. So as you can see, the students are working together to come up with their solutions and also debug. So they've done it together on the whiteboards, but I just wanted to show you how you might actually be able to do that online. So if you're wanting students to collaborate together at the same time, so instead of one person just being the scribe and you want all the students to jump in, Google Slides can be a really interesting way to be able to implement that activity. So just click on this here. So I've created some Google Slides, and what I would do is invite each team to create their own slide or have it pre-prepared. And on the slide, you could get them to write their own instructions, which then can be given to the computer programmers to implement. And what's really nice about this is that you can have multiple people jump in and edit the document at the same time. So everyone gets a say, and it might help the students who are a little bit quieter have a voice and be able to add their idea. And also as a teacher, you can actually keep this as a document to refer back to. But if you go up to the top here where the edits were made, you can actually go and click on this and see past revisions. So you might see the changes. So when they first gave their instructions, how did it change the second time around? What did they notice? Did their instructions become more explicit? And so on. And you might refer back to that at another lesson date as well.
While you move on to the next slide, just brilliant visual, thank you, from Stella. So thank you, Stella. And Sangeeta says, great idea, wonderful, thank you. And Dale, this is great. I learned these steps in year 9 and 10, making a jam sandwich many years ago, which is awesome. Natasha's having some problems with her connection, and the video is freezing. Don't worry, as long as you are registered, as long as we've got your contact details, you'll get a link to the recording, you'll get a certificate of registration, and you'll also get the handout and slides. So as long as you're registered, you will be able to watch this back at your own leisure.
Yeah.
Okay, back to Rebecca, thank you. And Rebecca, you've got about 30 minutes just to keep you on time.
I'm just going to close some of these windows as well.
You've got tab fever. I have that. It's a terrible disease.
Oh, how do I get that in the window? Sorry. Just going to try and reset that because I think it might have been slowing down a little bit. Okay, so can you see that, Chris? Is that okay as a full screen?
Yeah, no worries.
All right, great. Okay, so just moving on, I guess where to start with programming in the classroom when it comes to coding environments. I've got some examples here. On the right-hand side, we've got the Blockly games, and these programming environments activities as well are really great because they have tutorials. So they actually walk learners through step by step, and they introduce the programming statements and skills slowly and give students a chance to practice implementing those using code, whether it be visual programming or text-based as well. So I'm just going to click on one of these just to give you a look at how this sort of works. So we've got the Blockly games, and I really like this because I think the introduction to some of the programming concepts are really nice, especially with the maze activity. So I'll click on the maze. And as you can see, it's just a matter of learners dragging and dropping the little blocks so that the character moves to the endpoint. And this is a puzzle game, so it's about problem solving and getting them to think about how to formulate their algorithm. So you can see. And then you can see the actual code there. So a really nice strategy for working with this kind of environment is using pair programming. And what that involves is having one person be the driver. So that might be the person moving the blocks out, and one person being the navigator. And the navigator is helping to think about the bigger picture, but they're also thinking about perhaps potential problems or bugs, and they're helping the driver come up with a solution. And this is excellent because it really gets students thinking aloud, and I guess having a friend there or even just a peer to talk through the problem solving process makes them realize that you don't have to get it perfect the first time because you're both trying to figure it out. So that's just a nice strategy, and we use that with teachers as well when we run the workshops, which is fun. I'm just going to jump to say midway. And as you can see, the programming problems get a little bit harder, and they also introduce the new statements. So you start using things like the loops, and then you get to the very end and it's quite complex. So we've had teachers comment that they've used this in the middle years, which is about years three onwards for Australian students. And also I've had a teacher say she tried it with a reception class, which is the very first year of school. And she walked through the activity as a whole class. So she actually was the driver and moving the blocks out, and the little kids were helping her figure out the solutions. But with the younger years, you don't have to go through all the puzzles. You might just stick with the first few. But this is a really nice way to explore positional language and navigational language. So thinking about forward, left, right, particularly in the early years. And that's a nice way to actually combine that with unplugged activities and getting young students maybe to blindfold each other and walk through those instructions themselves. Okay, and I've got another one up here on the left. So this is the Made with Code website, which I mentioned before. They've got some really excellent activities around fashion and design, and even using things like GIFs and I don't know, sort of inspired by Instagram and GIFs and all the popular technology. I did an activity here where the girl is dancing and you're actually sort of programming up the top. You can see the visualization. So it tags where her movement is from her wrists down to her legs and so on, and it moves through the dance sequence. It also gives students an opportunity to share online. So whatever they've made, they can actually share that online. And down the bottom here, we've got the code.org website, and they've got some fantastic resources which they've sorted around particular, I guess, learning needs. And if you're using a tablet or unplugged, or the website as well. So you can actually go through there and find them based on what you're looking for. So there was a comment earlier about what programming language for high school students. So you might think about JavaScript, this kind of Khan Academy tutorial activity, which is a nice introduction to using those kinds of environments. And you've got more puzzles and apps and things like that. So what I do with workshops with teachers or students, I tend to like to pick coding activities that take people through a sequence of instructions and skills and allow them to practice those skills, but also that has an element of creation at the end. So I'll have a look through and check if at the end they have an opportunity to actually create a story or make their own version of the game. So that's something to keep an eye out for as well. Okay.
Sorry to keep interrupting, but just a couple of quick questions. Shani asks, is there a way to access that video or for it to be shared? I think she's talking about the video of the teacher doing the jam sandwich. That will be in the slide deck as a link, so you'll be able to get that, Shani. And also, this is a complicated question, which I'm not sure I fully understand, but you may well understand it, Rebecca. It says coding is a part of the Applied Technology and Tournament of Minds this year, primarily using Blockly. Is there a better option for high school students that can be shown without internet access? Does that make sense? If it does not, don't worry.
Yeah, so you're looking for something that you can run offline, like Scratch, I think. Probably, there's the processing language, which I'll get to after. Actually, it's on this slide here. I can talk about that a little bit now. So for the older students. Oh, sorry, is there another question?
No, we're good. That's an excellent segue to get back to you then.
Oh, okay,
thank you.
Great. Yeah, so I can talk about that in a minute. I'll just go to the one that I'd probably encouraged before as a nice progression into the processing language. So we've got Pencil Code, which is pencilcode.net. So with this one, you can actually integrate this with subjects like mathematics, and you can have students creating shapes using either visual programming, so the drag and drop blocks, or you can get them creating it using some text-based code. So I'll just click on this and we can have a little peek. So here you can see we've got draw, or you can integrate it into music perhaps, or even just imagine. So we'll go to the draw option. And in this one here, so you've got a whole list of activities along the left-hand side, and they have different challenges, I guess, and different ways of getting students to problem solve to create shapes. So in this one here, I'll just click on this example. So this example uses the visual programming, and as you can see, someone's dragged all the sequence of moves there, and the little turtle here, he's going to act out those instructions. So if I click run, you can see the little turtle moving around there, and he's going through the sequence of steps. So this is the visual programming version. Then if we go down further, we can actually see activities where you start to use the text code. And in this one, that was the screenshot that I showed you earlier. We're telling the turtle to draw a star. So we'll just click that and have a look. But of course, students can go through and actually create their own shapes. But what's great about this is it's really nice way to teach mathematics. You're just using code as a tool, I guess. And in this activity, students are learning about geometry. They're learning about the different angles of shapes. They're learning about I guess, length. And they're also having instant feedback. So they can actually play around with, changing the degrees and actually seeing what impact that would have on a shape and getting that instant feedback, which is fantastic. And these kinds of activities could lead into creating patterns or their own artwork or maybe even a logo of some sort. So I'll let you explore that at another time. So I'll just go back to this one. We've got processing.org, and I guess this would be the next step up from using something like pencil code. We use this with our introduction programming course on edX. So as CSER, we actually released a free open online MOOC, and it was about learning code through creating digital artwork and animations, which is lots of fun. And here you can see an example of the students' artwork from the final week. So what's happened here is you've got the text on the left-hand side. I didn't want to scare you with it, so I haven't actually made it a large image. But on the right-hand side, you can see the little image here. And this is actually an interactive one. So when you go and click on it, the little boat moves across and the water glimmers under the sun, and the sun actually sets, I think, which is really nice. So that's the final level, but you can actually start off really simple with processing and just create basic shapes. So it might be drawing a square, drawing a circle, and then slowly adding things. So it could be as simple or as complex as you want. And I've got the website there, which is processing.org. And so you can see there, it's free to download. You can actually run it on your computer separately, so you don't need the internet to run it. And there's a lot of tutorials online. Some are quite advanced, but if you actually search processing hour of code, there's an hour of code step-by-step tutorial, which I'll link into the slide deck here as well. But that's a nice way to introduce with high school students, I think, when they start getting into that general purpose programming. Okay. So I guess now I wanted to just have a little look at how you might integrate coding with literacy or English or even languages. And we've got here the Scratch example, which some people have mentioned as well. And on the left-hand side here is a screenshot of what your Scratch environment would look like. And you've got the fish here, which is in the preview area. So that's where all the action happens. On the right-hand side, you can see the algorithm. So where the code blocks have been snapped together to create the instructions. And in the middle here, you've got the code blocks that students can choose from to create their instructions. And I guess this is a really nice environment for creating stories, animations, games. You could tie it in as another way of creating a digital story. So instead of having students doing stop motion or writing a story themselves by hand or on the computer, you might actually invite them to take that story and create it in a digital format. It could also be integrated into science. I've seen some students create explanations for how, say, a caterpillar grows, or the life cycle of a plant. It could be how cells work, so integrating it into biology. And there's some really interesting Scratch projects. So the good thing with Scratch is you can actually go to their website and search for existing projects that students have created. So you can actually see what's out there and sort of find inspiration for activities around that. I'll just click on it so we can have a quick look. So if I go cell biology, perhaps up in the top of the screen here, and just search the projects, you'll find we've got some cell division on Scratch. So this is a project contributed by a student. You've got a simple cell on Scratch. Even some teachers actually create their own projects as a way to explain ideas to students, which is quite neat. Okay, so I'll let you explore that in your own time. You can have a look at the Scratch environment. There's a lot of online YouTube videos where educators have actually done step-by-step instructions, which are fantastic. And they've also given ideas around how to integrate it into the classroom. So I encourage you to go and have a look on YouTube. We've also got Scratch Junior, which is a new one that you can get on the iPad or the Android tablets. And this is, as you've seen, the large symbol block. So it's just for the early years, but students can still create animations and stories. And we'll just have a quick look at how that kind of works. So you've got here students looking at some of the resource handouts that they've got on the website. So if you go to Teach, they've got fantastic web resources here where you can print these out and have students follow the instructions, say as an introduction to how to use the environment. But then you can invite them after they've built up their skills to create their own open project. So it might be a story or something. Okay, and as you would with, I guess, exploring narratives in the classroom, using storyboards is a really nice way to get students to break down their idea into smaller tasks and think about how they can go about creating their solution. So it can be quite overwhelming, perhaps initially, to look at an empty Scratch canvas and think, well, what am I going to create? So just to take a step back sometimes and really think, what if I'm creating a story, if I've got 6 scenes, what's going to be in each of those scenes, and how can I tell the story? So I've just got a Google Doc here where I guess I've brainstormed some examples to show you. So what I'd consider in a storyboard when you're using Scratch is the scene. So what might the scene look like? What characters do you want in there? And what would they be doing or look like? And then underneath, I would consider as well, what are the actions? So what's happening in that scene, and perhaps any dialogue. So you might have here for the scene, a background will be underwater with coral and bubbles, and there'll be a fish and a crab. And then the actions might be that I want the fish to swim across to the crab, and then the fish says, "Are you okay?" So that's sort of just breaking it down, and then it helps me when I think about going and creating that code. You might take it to the next level and actually get students to think about what blocks they might need to implement those actions as well. Okay, so I guess I don't want to spend too much time on this because there's so much excellent technology out there, but if you're looking to start going further and creating digital solutions, there's some nice plugins that you can do with Scratch. So we've got the Makey example up here. So if you go to makeymakey.com, you can actually plug this into existing Scratch projects. So projects that have an element of sound are really nice because the Makey actually becomes your new keyboard, and you can use the alligator clips to plug into things like fruit or Play-Doh and alfoil and other conductive items. So here we've got some examples where teachers, so we've got Sally Walsh and Meredith Epps, they've had their students create makey controllers to play the games that they've made, and also to design musical instruments. And we recently tried that at the Science Week here in Adelaide and had students creating their own musical instruments, which is really, they loved it. They were so excited. We had people that came back the next day. So that's an interesting one. Also, you've got your mini computers, which is things like your Raspberry Pis and your Galileo boards. And if you actually Google some of these technologies, you'll find that there's so many resources online and people sharing their ideas and documents for how to actually implement the lesson plans. Raspberry Pi have a nice website, and Intel by Galileo have the innovation toolbox, which I've linked in here into the slide deck as well to get you started. How are we going for questions, Chris? Is there any?
We're okay on questions in the Q&A app. We've got tons of people who are tweeting stuff, so that's fantastic. Thank you. Mainly just comments and answering some of the questions as well, but sharing some resources. I've just shared a resource on Twitter using the hashtag NextPractice, which is an iTunes U course that was written by John Monash Science School teachers and Monash University academics around algorithmic arts. So it's a little bit out of date. It was about 3 or 4 years ago we wrote it. And I taught it, not having any experience on how to code at all, using Scribble, which is a kind of a bespoke version of Scratch as well. So yeah, so there are some great sharing of resources on the tweets, and I don't have any questions for you, but you have about 10 minutes left to go, if that's okay.
All right, that's great. So I guess one of the things that I wanted to pick up on was some things focused around designing solutions. So how can you help students design their solutions when they're coming up with their coding projects? And flowcharts are actually one way that we get students at university to think about designing their solutions. And it's also a really nice way to introduce coding design into your classroom as well. So they could be simple flowcharts. So you might actually just show how things work in a logical order, or you might start to introduce things like decisions and branching and loops as well. So I've got here on the left an example where I've actually just started to create a little flowchart using symbols in the Google Slides. And I've just gone and used things like the shapes. So if I click up at the top here, I can go to shapes. And if you hover over the top of the shapes, you can actually see that there's specific names for each of the shapes. And they actually match up with actual programming designs. So for computer scientists, they have particular shapes that represent different things in the design process. So the decisions is usually a diamond, and the start is like an oval. So what you can do is actually get students to even research or have a look at what those symbols mean, and I guess try and incorporate them into the designs. So another one here I've got is I've used a plugin tool. So you can use things like Glyphy, and I've put that in the handouts sheet, or you can use something like Lucidchart. So this one here is just using a little add-on through Google Play called Lucidchart Diagrams. And I added that by actually going to Get Add-ons, and I just searched Lucidcharts. And then it pops up if I add it as one of my add-ons here. And as you can see, I can insert a new diagram, or I can update an existing one. So I'll go insert and just show you. It pops up on the right here. And you can actually see some of the flowcharts that I've made here. But what you can do is you can click on one, so my algorithm. You can edit it in your document. So I've just got the sample version, but you can actually, with your .edu or university or education email address, you can actually get the premium, I believe, for free if it's a student account, which is helpful. So I'll just go not now, but it's just a matter of dragging and dropping a little sequence of instructions out and then connecting them together just to show where the process, how the process flows. And you can just click on them and edit the little text box there, like that. Okay, but if you don't want to buy the tools, you can actually do this in Google Docs, which is awesome. And I've just done this by using the little up here, if I go insert, and I've used the drawing tab there. So if you click on the drawing tab, it will open up with a new one, and you can start dragging and dropping your shapes, just like the Google Slides, into your little program there. And the same thing like with the flowchart design tool, you can just actually connect the lines together. So I can connect these just to show the flow and things like that. And you can just, if you double click on the shapes, you can just start entering your text and what you want to show the design process. Okay, so I guess that one's just really good for developing computational thinking. So you're using decomposition, also abstraction in getting them to think about, what's the overall solution. And your flowcharts can actually be used as a tool for reflection. So it could show development of how you're thinking about things. It can also be used to debug. So here I've got an example of a game. And if I'm having an issue with my game, I might actually take my flowchart and look at it and think about where is it going wrong? Why isn't this working? Perhaps I need to add a condition somewhere, and you can maybe share it with get students to share it with one another when they're pitching their ideas. Okay, so and just lastly, I won't go into it, but you've got the stage where you're thinking about reflecting on solutions. And one way to engage students in reflecting on their solution could be to have their peers look at what they've designed. So you might get them to play the game if it's a game, or look at the animation. It could involve their peers looking at the code as well and some kind of critiquing it or providing feedback. But it's also important because students put a lot of effort and heart into what they've created. So you need to encourage students to be sensitive about the feedback and provide constructive feedback. And Chris Hart actually, in his webinar, he explored ways of thinking about providing constructive feedback that's positive, and it's effective and it's useful. And so if you haven't seen it already, I really encourage you to go and look at his webinar there and have a look at that. So he'll share the link back to the webinar page after, but I just thought the points that he touched on were fantastic. And I've just used Google Forms as an example in the link there that you can explore later. It's a nice way to get feedback as a survey tool, but it also visualizes the data instantly. So I can actually, if I click on this, I've got evaluation of my game. So I might send this link out so you can view the live form. I've just edited these. Then I might get people to just respond. They can submit their answers about my game. And what I can do, or they can do, is actually see the previous responses. And the Google Analytics actually takes the responses and presents that really nicely. So here I can see, for example, people loved my game, but there were a lot of responses about feedback, which needs more information in the instructions. So I might actually go back to my game and they enjoyed it, but I might just add more instructions. Okay, so if you haven't already got a club in your school, I just want to do a plug for some of the clubs that you can start in your schools or your community. So even if you're in a library, you might start a club, which is fantastic to get students engaged, working on projects together or individually. And it's a nice way to tie into perhaps some, big programming or big ICT conferences or events and competitions. Okay, and for further professional development, if you enjoyed some of the content today, we've got our CSER Digital Technologies MOOCs. We've designed these for Australian teachers, and it's to help them implement the computing curriculum. But Google also have a computational thinking course, which is linked in your slide deck. The round's just finished, I think, but I'm pretty sure it was a fantastic course, so I'm sure that they'll open it up again. And both of these have really fantastic Google Plus communities where teachers are actually sharing ideas and networking. So I highly recommend later on, if you get the slide deck, and just pop in and have a look at those courses. Okay, so they're my contact details. If you want to get in touch with me, reach out on Twitter. I'm happy to answer any questions on email. And that's our CSER website if you want to stay tuned with what we're doing.
That was absolutely wonderful, Rebecca. Thank you so much. Can you just leave on that last slide for me? That would be brilliant.
Sure.
Listen, absolutely fascinating stuff. What I loved more than anything else was it takes away a little bit of the fear of coding. You know, some people think, oh, I need to be some, computer genius to be able to get my kids to code. Whereas in fact, what I loved were your examples, which were more about computational and algorithmic thinking and getting kids to think that way. And there are lots of technologies that can help you to actually implement that algorithmic thinking, which is just fantastic. My own child, who is a naughty boy and won't be getting any Christmas presents this year, last Christmas he got one of those Kanos. So it's like a little set with a keyboard, and it's essentially a Raspberry Pi. And he was learning to code using that and hacking Minecraft. So there are some wonderful technologies out there, but the important thing is about developing that algorithmic thinking. So thank you once again to Rebecca, absolutely wonderful. If I can just send you to that website, which is www.uldtraining.com/webinars. You will find not only recordings of all of our previous webinars, so we've looked at literacy, we've looked at Google Apps, we've looked at building communities, we've now looked at coding. So please do jump on there. You'll find the recordings of the past webinars. We also have the recording of this webinar will go up there in a few days. If you've registered, you will get a link directly to the recording. You'll also get your registration certificate, and you will also get a link to the slides and Rebecca's handout. Next week, next Wednesday, we are running another Google for Education Next Practice webinar on primary focus with two wonderful primary teachers from Frankston, from Melbourne. So Sarah and Marissa, so please do join us there. The registration form is on the website that you can see in front of you on the uldtraining.com/webinars. If you do have any feedback, we would love to hear from you, but can you please make it kind, specific, and helpful, which was the critique I think Rebecca was referencing before, and email me, chris@uldtraining.com. Or if you want to make it public and add a comment to the events page. Thank you again so much for joining in. I do want to plug Google Apps for Education in particular, who support these webinars and help us to get people like Rebecca to connect with people like you. It does make a huge impact. It's a very different way of doing PD, and it really warms my heart to see over 200 people registered for this kind of professional learning activity, I suppose. So thank you very much. I do want to say thank you once again to Rebecca. You're amazing. I can't find my hands. I'm trying to wave at you. So thank you so much, Rebecca.
I just want to say thanks to Chris for hosting these webinars and for inviting me just to share about coding and computational thinking. The feedback has been that teachers have really enjoyed these webinars. I've watched them, and I think that the other webinars are really good. So if you haven't seen them, do get on there and have a look.
Fantastic. Thank you so much, Rebecca. Well, everybody, I'm going to stop the broadcast now. Once again, thank you so much for your time, and have a great rest of the day/evening wherever you are.